Hey everyone, welcome back to What If? In today's marathon of information, we're going to be looking at mind-blowing mysteries in space. Space civilizations, the most terrifying planets in our universe, even white holes. Yeah, you heard me right, white holes. I bet you didn't even know those existed. Today, you're going to learn so many things about space that you didn't even know were possible. Forget all the lies you were told. Today, we're giving you the real breakdown. First, let's talk about how scientists have found traces of a Type 2 civilization in outer space. What technology are they using to power their civilization? And should we be scared of them coming for our resources? Let's find out. Researchers have detected strange radio signals coming from deep space. These mysterious radio waves might just be bursts of cosmic energy from a distant neutron star. Or it could be that scientists have discovered a highly advanced civilization 90 light years away from Earth. So, what kind of civilization would have the ability to send strong signals like this? Well, scientists classify civilizations on something called the Kardashev scale. It's a scale that measures a civilization's technological ability to harness energy. While it's a hypothetical scale that could eventually have 5 or more levels, most scientists only refer to the first few. But don't be underwhelmed. We're the only civilization we know of, and technically, we're still stuck on Type 0. At this stage, we've managed to harness some, but not all of our planet's potential energy. We consume about 18 trillion watts of power every year, and if we wanted to bump ourselves up to a Type 1 civilization, we'd need to consume over 500 times that every second. To do this, we'd need to harness, store, and utilize all of the energy available to us. That includes all raw materials and every bit of sunlight that reaches Earth. We'd also have to tame volcanoes, earthquakes, and other natural forces. At the rate at which we're developing now, it's possible that we could be a Type 1 civilization within the next 200 years. But whatever civilization scientists may have discovered in the far reaches of space could already be a Type 2 civilization, or higher. Once our civilization has all of the energy available on our home planet under control and we graduate to a Type 1 on the Kardashev scale, then we need to take the next step. Time to crank up our energy consumption to 10 billion times what it was before. To do this, we'd need to harness not just all the solar energy that reaches Earth, we'd need all of the energy our star generates, period. If there is a Type 2 civilization out there, they're probably using an incredible system to do this: a Dyson sphere. They'd build this megastructure around their star to collect all the energy it radiates out in every direction. They could even assemble other Dyson spheres around the first Dyson sphere to guarantee that little to no energy escapes. But there's nothing simple about this technology, and that's why only advanced civilizations could construct something like it. For one, a Dyson sphere must be larger than the star itself. And if these megastructures are bigger than stars, well, they should be easy to spot, right? Well, this could be tricky. Once a civilization is finished building the Dyson sphere, the megastructure blocks nearly all of the visible light from its star. A civilization this advanced could make its own solar system invisible. Lucky for us, visible light isn't the only way to detect a star. Even with a Dyson sphere blocking its light, a star would still radiate heat, and we could detect the star by the infrared light it gives off. But that wouldn't be the only way we might discover a civilization this advanced. Remember that strange radio signal? It originated about 90 light years away from Earth, coming from the star HD 164595. Was this powerful radio signal created by an alien race and intentionally pointed toward Earth? A civilization able to pull this off would need to be far more advanced than our own. This Type 2 civilization would be able to utilize the raw materials on every planet in its star system, and maybe even beyond. They may have built fusion reactors that orbit their planet, fueled with gas from other worlds with hydrogen-rich atmospheres. And they might be mining precious metals from rocky planets, just like Earth. They could terraform other planets into livable worlds for their populations, and they wouldn't live in fear of civilization-ending natural disasters like asteroid impacts, ice ages, or global warming because they'd have technical solutions for these too. This alien civilization would be at the stage on the Kardashev scale where they'd be able to master interstellar travel. But if that's true, there should be no reason for them not to pop by for a visit, right? Well, not so fast. With all the advanced technology they might have at their disposal, these aliens could be waiting for us to catch up. That way, when our civilizations meet, we would do so as equal partners. Who knows? They could be so advanced that they're no longer a fully biological race. They could be more like cyborgs with a mix of robotic and organic material. This would make them capable of incredible things that humans could only dream of. But they wouldn't stop there. An advanced world like this would want to go farther up the Kardashev scale, and as they became a Type 3 civilization, they'd rely on something other than the power of their own star system. They would harness the power of several stars in their galaxy. With this much power, a civilization would have no problem meeting its ever-growing energy needs. They'd just hook up another star when they needed more power. If we ever advanced to this level, we'd have 100 billion stars available to harness in the Milky Way galaxy alone. A civilization like this would no doubt be the rulers of their galaxy, and they'd have the power to move entire star systems, merging them to harvest the energy they need more efficiently. So if one of these civilizations existed, well, you could detect them by observing the sudden disappearance of many stars in a faraway galaxy. This could be a sign that Dyson spheres have been constructed around not just one, but several stars. A Type 3 civilization could already be out there. After all, scientists have announced that they've found 2 galaxies with a highly unusual amount of infrared light. This is something we usually observe in galaxies where new stars are being born, but some unusual and sudden spikes in infrared light could mean that we've found the first signs that civilizations many times more advanced than us exist. Maybe they're about to make contact. Or maybe they already have. Our sun looks nothing like this. It looks more like this. If you've always thought our sun was a bright yellow ball of fire, you were wrong. For starters, it's not yellow, it's green. Sort of. Scientists determine the temperature of a star by the color spectrum it emits. Each color has its own wavelength, and astronomers measure those wavelengths to tell how hot a star is. Cooler stars appear red, the hottest of the stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it also emits other wavelengths, all these colors mix together, and your eyes see this vibrant mixture as white. That is, if you look at the sun from the International Space Station. From here on Earth, the sun looks yellow because our atmosphere is really good at scattering blue light. And with all that blue wavelength gone, all the other colors combine into yellow. If our star was actually yellow, it would be about 800 degrees Celsius cooler, our solar system's habitable zone would shrink, and Earth would become a frozen, lifeless rock. But that's not the only thing you were wrong about. The sun is hot, but it's not on fire. Burning is a chemical reaction of oxygen with fuel. Like most stars out there, our sun is a ball of gas, mostly made up of hydrogen and helium. It doesn't have much oxygen in it. Instead, it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so scorching hot. Speaking of setting things on fire, let me tell you about explosions in space. Yeah, these aren't real. A spaceship can't go down in a violent blast because there's no air out there in space. No air means no oxygen, and no oxygen, well, as you already know, means no fire. Sorry, Star Wars fans. It may seem that there are too many stars in the night sky for you to count, but actually, you can. Although scientists at Harvard have already done it for you. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the naked eye. Try to count them all for yourself. Movies make it look like you need to be an extremely skilled pilot to navigate the asteroid belt, but that's not true. The asteroid belt isn't some thick obstacle course of death. It does have trillions of space rocks that range in size from space dust to a quarter the size of the moon. About 100,000 of these asteroids are over 1 kilometer wide, but they're very spread out. The asteroid belt between Mars and Jupiter is 225 million kilometers across. That's 1.5 times the distance between Earth and the Sun. And this spreads the space rocks millions of kilometers apart. It's almost impossible for a spacecraft to collide with one. If you were thrown out of the airlock into the vastness of space, you wouldn't turn into a popsicle right away. That's because to freeze, there has to be a heat transfer from space to your body. But heat, or cold, doesn't travel very fast in the vacuum of space. Your body would freeze, but it would take hours to happen. And by then, you'd be long dead from something else. And no, you wouldn't explode in space either. You would inflate, though. That's because nitrogen in your bloodstream would gather into bubbles and puff you up to double your size. But that's not what's going to kill you. It's the lack of oxygen. After 15 seconds in space, your brain wouldn't get enough oxygen through your blood, and you'd lose consciousness. After 2 minutes in space, your other organs would start to shut down one by one. Game over. Space seems incredibly cold, but it's not. In reality, space doesn't have a temperature at all. Temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around. That's why the vacuum is temperatureless. Of course, outer space isn't a perfect vacuum. It still has particles and radiation to produce heat. Some areas of space are actually really hot, like the space around stars. But the further away you get from stars, the more spread out the particles are, making those areas of space pretty chilly. Some dense gas clouds can get as cold as minus 263 degrees Celsius. Mercury is the closest planet to the Sun, but surprisingly, it's not the hottest. It is extreme, though. During the day, the surface temperature reaches 430 degrees. And at night, it drops to minus 180. Oof! But the most hellish planet in the solar system is Venus. You see, Mercury doesn't have an atmosphere to retain all that heat from the sun. The Venusian atmosphere, on the other hand, is very thick and it creates a greenhouse effect. It's like global warming on steroids. And it makes Venus a hot hell with a surface temperature of about 475 degrees. Our entire solar system isn't just sitting in one spot in our galaxy. It's hurtling through space at 220 kilometers per second. That's 7 times faster than the speed that Earth revolves around the Sun. Our solar system takes 230 million years to make one orbit around the Milky Way. Yeah, the last time we were in the same location we are now, Earth had one supercontinent and the dinosaurs were just starting to roam around. Planets do not orbit around the Sun. All the things in our solar system are in balance, and even though the Sun is the most massive object in our planetary neighborhood, other planets are participating in this gravitational tug-of-war. Instead of orbiting the Sun, planets and moons orbit around a central point between them and our star. This point is called the barycenter. For Earth, this barycenter is so close to the Sun's core that there's not much of a difference, but for Jupiter, this point is about 55,000 kilometers away from the center of the Sun. So the gas giant and the Sun are orbiting each other. Earth appears round from space, but it's actually an irregularly shaped ellipsoid. It bulges at the equator thanks to the centrifugal force caused by our planet's spin. As a result, Earth is about 43 kilometers wider at the equator than it is at the poles. This makes gravity at the bulge slightly weaker, making it easier to launch spaceships from the equatorial regions than from the poles. In space, no one can hear you scream. That's only true to a point. Sound needs a medium to travel through, and in space, molecules are very far apart, so the sound fades away before it can get very far. All the cosmic catastrophes, supernovas, and colliding black holes go quiet before you can hear them. But some places in space have a lot of particles for sound to travel through. Like the hot gas cloud around the black hole at the center of the Perseus galaxy cluster. It has so much gas that you can actually hear the black hole. This is what it sounds like. I don't know about you, but I feel a little betrayed. I mean, how did I not know that the Sun was green? And you mean to tell me planets don't orbit the Sun? I can't stand being lied to. You know what else they lie to you about? How cool it would be to live on other planets. Like if we lived on a planet that looked like Earth but wasn't. Well, guess what? Scientists have found an Earth look-alike, and it's horrifying. You wouldn't stand a chance. They've also found space's very own Bermuda Triangle. I'm already petrified of the one here on Earth. How the heck do we avoid the one in space? First, let's take a trip to our twin planet, HD 189733b. This blue marble-like planet looks just like Earth, but only 5 seconds on this hostile death orb would kill you. Welcome to HD 189733b. This planet is enormous, even larger than Jupiter. And to keep comparing it to the largest planet in our solar system, it's also entirely made of gas. That's why scientists classify HD 189733b as a hot Jupiter. This planet is located so close to its star that it completes its orbit in just over 2 days. Yeah, HD 189733b is 13 times closer to its sun than Mercury is to our sun. And even though its star is cooler than ours, this fake Earth is still way outside its star system's habitable zone. That means no liquid water can exist on a planet's surface. Just how this giant gaseous planet developed so close to its star is still a mystery. One theory is that HD 189733b formed right next to it during the star's earliest moments. Or it could have developed further away, only to be pulled in as the rest of the planetary system formed. But there's one thing we know for sure. A visit to HD 189733b would be a plunge into hell with no chance of escape. Now, even if you knew there wasn't a single drop of liquid water on this planet, you'd have a hard time believing it as you approached the giant blue marble. With an average daytime temperature of nearly 1100 degrees Celsius, this planet is twice as hot as Venus, and Venus is the hottest planet in our solar system. One of the reasons for this intense heat is that the planet is tidally locked to its star, just like our own moon is to Earth. That means HD 189733b takes as much time to spin on its axis as it does to revolve around the star. So one side of the planet is constantly in daylight, while the other side is shrouded in darkness. The inviting look of this world doesn't come from its oceans like it does here on Earth. No, this hellish planet gets its color from clouds of molten silicate particles. These particles scatter more blue light than red, making the planet appear blue. Silica is the primary ingredient in glass, and you should bring a heavy-duty umbrella because you'd need to take cover from what would essentially be hot, molten glass rainstorms. But that's not the only danger. You'd need to be ready to brace yourself against the extremely powerful winds that you'd find sweeping across the planet. With speeds up to 7,000 kilometers per hour, these gusts are almost 30 times stronger than even the most powerful Category 5 hurricanes on Earth. Compared to the strongest winds on other planets in our solar system, HD's winds are almost 4 times stronger than those on Neptune. But hey, they might smell a little better than the ice giant's hydrogen sulfide clouds. Those carry a whiff of rotten eggs. HD's winds are so fast that they'd whip past you at about 6 times faster than the speed of sound. They would be extremely loud, but I think you'd be more worried about them tearing your body apart. You might be long gone by now, killed by that molten glass rain. In any case, you wouldn't last too long on HD 189733b. I really don't recommend traveling there. But there are some planets out there that can kill you even faster. Check out OGLE TR56b. This gas giant sits in a galaxy nearly 100 light-years away from Earth. It's even larger than HD. Its mass is nearly 1.4 times as much as Jupiter's, and somehow, it's even closer to its star, too. You'd find this world to be incredibly scorching hot. Surface temperatures on this planet average around 1,700 degrees Celsius. That's so hot that it turns metal to gas, creating iron clouds in the upper atmosphere. If you got caught in the rain here, you'd find it to be an extremely unpleasant and deadly shower of hot molten iron. Your skin would burn right off, and so would your insides. But things could get even hotter. Some 670 light-years away from Earth, there's a planet so hellish that it's tearing molecules apart. Meet Kelt 9b. This gas giant is almost 3 times more massive than Jupiter. It takes Kelt only 1.5 Earth days to speed through the orbit around its sun. And just like HD 189733b, it's tidally locked, with one side always facing the hot star. Landing on this planet, you'd experience temperatures as high as 4,300 degrees Celsius. It's the most scorching exoplanet we've ever discovered. Scientists call this gas giant an ultra-hot Jupiter. And those high temperatures also make Kelt 9b hotter than most stars in the universe. So hot that it would destroy you. Come on, this world rips apart molecular hydrogen gas. What do you think it would do to your body? But before you even arrive on this hot planet, you'd be exposed to deadly amounts of radiation coming from its host sun. Yeah, Kelt 9b receives about 44,000 times more energy from its star than Earth does from the sun. This radiation would cook you alive instantly. Okay, if you somehow managed to survive all the lethal radiation of Kelt's star and the unimaginable heat of the planet, well, you'd still have to take on its incredibly strong winds. Scientists think those winds could reach speeds of 60 kilometers per second. Yeah, that's 30 times faster than the winds on the deceivingly Earth-looking planet HD 189733b. Okay, so if I get this straight, Kelt 9b would swirl you, burn you, and tear your molecules apart. 1 out of 10, would not recommend. If you think meeting your demise on these kinds of hellish planets could be fun, well, I have some better travel suggestions for you. You know, not everything out there in space is utterly terrifying. There are planets that orbit their stars at a safe distance, just like the Earth orbits the Sun. Did you know that there's a mysterious area in space where astronauts are unable to communicate with home base? They're exposed to extreme levels of radiation, and their spaceships start to malfunction. It's being dubbed the Bermuda Triangle of Space. This area has perplexed scientists for decades, but astronomers may have finally solved this outer space anomaly. What exactly is the Bermuda Triangle of Space anyway? Well, its official name is the South Atlantic Anomaly, or SAA for short. It's hovering above the South Atlantic, stretching from Chile to Zimbabwe, and this area has a considerably weaker magnetic field when compared to the rest of the Van Allen radiation belt. The Van Allen radiation belt is a pair of cosmic donuts surrounding Earth. This is a unique location where the radiation belt comes closest to the Earth's surface. These belts trap particles that shoot from the sun, which protects the Earth from harmful radiation. The solar radiation within the South Atlantic anomaly isn't held back to the same degree, though. But why? Well, to explain that, first let's dive into what happens if you wander into this terrifying part of our solar system. The SAA is known for causing electronic malfunctions in spaceships and extreme radiation exposure for astronauts. It can completely destroy spacecraft. In 2016, the Japanese satellite Hitomi came crashing down to Earth after satellite operators began getting mixed signals from the ship. It was reporting inaccurate data about how it was performing up in space, making people down on Earth think that everything was fine, but this was happening as it traveled through the SAA, so operators weren't aware that there was a problem and couldn't take steps to correct it. The Hubble telescope, luckily, has managed to avoid any issues while traveling through the SAA. That's despite spending a whopping 15% of its time in the space anomaly. To protect the telescope, satellite operators power it down. If they didn't, the SAA could corrupt any precious data that's being collected and potentially crash. But how do astronauts deal with these heavy levels of radiation? Well, their radiation levels are constantly being monitored, so if they do end up in the anomaly, they have what's known as a water wall. Certain rooms on ships are filled with these massive bags of water, and if you stand behind them, they'll protect you from radiation. Water is the best thing to shield you from this harmful energy because of its high hydrogen content. Now, if they didn't have this water wall, they could get severe radiation poisoning or even cancer. So we know the radiation levels are much higher and more dangerous in this specific part of space, but why is it happening in the first place? Well, despite what pictures might show you, Earth isn't completely round. It bulges around the center, like me. And because of this, the Earth's physical center and its magnetic center are slightly off by about 500 kilometers. This offset means things like cosmic rays can get closer to the Earth's surface near the bulging area. Luckily, the Earth's magnetic bubble can still keep all those dangerous rays from getting to us, but that's not the case for people in space above the South Atlantic. Because of this, stronger radiation levels can reach this point up in space, and what's even more concerning, due to the fact that the magnetic poles here on Earth are constantly changing, the South Atlantic anomaly keeps growing. It's also gotten weaker by 15%, meaning the radiation has gotten stronger in the area. So NASA has been carefully monitoring the SAA since 2019. They've noticed that the anomaly is moving west. And what's even weirder, the anomaly is also splitting in two. If this continues, it could make things even more complicated regarding space travel and data collection. But luckily, for it to change significantly would take millions, if not billions of years. So, this Bermuda Triangle of space isn't as mysterious as it sounds, and astronomers are getting better at handling it with every new ship launch and every piece of data recorded. You know, like a lot of you, I've been fascinated by black holes my whole life. Trouble is, scientists tell us that we'd get spaghettified if we ever got close to one. Our bodies pulled apart into strands, like giant spaghetti. So maybe exploring a black hole is out of reach. But did you know scientists have discovered a white hole in outer space? I know I didn't. What does this even mean? If black holes turn us into spaghetti, would white holes turn us into macaroni? Maybe some rigatoni with Parmesan? Not likely, but white holes are a cool concept. If you could somehow defy the laws of science and make it through one, you could enter another universe. Now, what's even cooler and a little easier to comprehend is that scientists have discovered an exoplanet that could host life. And after everything you've learned so far, you might be a bit skeptical of leaving Earth. And I'll be honest, this planet might not be the best for humans either. But what about hosting alien life? A black hole is a celestial whirlpool of gravitational death. Things can go in, but they can't get out. But it turns out that one of the most powerful things in the universe could have a mysterious twin. A white hole. Yeah, this beast isn't exactly like a black hole. Black holes are incredibly dense objects that squeeze all the matter they ingest into an infinitely small point at their center, a singularity. Most black holes are remnants of massive collapsed stars, so they have a lot of mass condensed into that point. And a lot of mass means a lot of gravity. Every black hole has an event horizon. This is the boundary surrounding them that marks the point of no return. To escape from the event horizon, you'd need to be able to travel faster than the speed of light. White holes are the opposite. In the same way that nothing can leave a black hole, nothing can enter a white one. That's why scientists theorize that white holes might be the other side of a black hole. Rather than consuming matter, a white hole constantly ejects it into the universe. If not back into our universe, it could be a gateway to another. Now, while we've observed and even captured an image of a black hole, we've never seen a trace of one of its white twins. But scientists may have finally found the evidence they've been looking for. Mysterious gamma rays showing up where they shouldn't be. Gamma ray bursts are short-lived bursts of gamma ray light that last from a fraction of a second to a few minutes. And in this short time, they eject as much energy as our sun does over its entire lifetime. Gamma ray bursts are the most energetic events in the universe. They could be hundreds of times brighter than a supernova, and they happen when a black hole is born. But scientists found one very unusual gamma ray burst. It seemed to appear out of nowhere, only to collapse on itself very quickly. And even though it lasted about 100 seconds, it behaved like a much shorter burst. This particular gamma ray burst, called GRB 060614, didn't have the usual afterglow that comes from a black hole. And that's why scientists think this might be the proof we needed of a white hole. So it's time to check it out firsthand. If you traveled across the universe to catch a glimpse of this theoretical white hole, what you'd find would look like a black hole. A dark emptiness, a ring of dust and gas separated by an event horizon. But you wouldn't slide into the center of the singularity. No, instead, things would get rough. Your spaceship would be blasted by intense gamma rays, destroying it and everything inside. Now, even if you could survive that with the help of super advanced gamma protective technology that doesn't exist yet, you'd still never be able to enter the event horizon of this white hole. It would be like immense air resistance back here on Earth. The ejected radiation would constantly slow you down. Add to that the challenge of moving through space-time that's being warped around you, and it would almost be like you were traveling uphill with an extreme wind blowing you away. You'd need more energy to overcome this resistance and push forward. And the closer to the white hole you get, the more energy you'd require. There would come a point where you'd need more energy than there is in the entire universe. But there might be another way in. If a white hole truly is the backside of a black hole, then traveling into its singularity would be like going through a black hole in reverse. But now, not only would you be competing against the powerful forces of gamma radiation, but you'd also need to overcome the impossibly powerful forces of gravity working against you. Oh, and you'd need to travel faster than the speed of light. Of course, that's impossible. Nothing can travel faster than light, but you might be able to get to your destination by jumping into a black hole first. Scientists think that there might be a wormhole connecting the white hole to its black hole companion. This could be your only way in. Except this passage would be extremely unstable. The entire thing could collapse unpredictably at any moment. I doubt you'd want to be inside when that goes down. Don't say I didn't warn you. If you were brave enough to jump into a black hole, well, you'd have to pass its event horizon. Once you were inside, you'd see another energetic burst of bright light. After this, the black hole would seem to expand all around you, surrounded by a ring of light. You'd be feeling pretty disoriented by now, and it might almost appear as if you were free-falling back through the black hole. This wouldn't be the case. This is just an optical illusion known as relativistic beaming. And of course, this wouldn't be the only extreme effect you'd experience. You'd still need to do the impossible and somehow break the cosmic speed record. Traveling faster than the speed of light, you'd be overcoming the most extreme forces of gravity pulling at you from behind. And because of that, your entire body would be stretched out very thin. This would be reverse spaghettification. And finally, the disorienting effects of the relativistic beaming would make it appear to shrink ahead of you, like you're getting further and further away. But eventually, you'd overcome all that gravity and blast your way out of the event horizon. And now, you'd be spewed out the other side of the black hole into a completely different part of our universe. Or maybe not even in our universe at all. Yeah, come on, you just traveled through a black hole and then a white hole. Anything's possible. 13.8 billion years ago, all the matter and radiation that makes up our universe emerged out of a singularity. Maybe you just traveled through the black hole that created our universe. It sounds like you've got another epic journey of discovery ahead of you. But it might not be as easy as you think. It's possible you've entered a universe with entirely different laws of physics than the ones we know of. You might be better off checking out something else that scientists have discovered. 120 light years away from us, there's an exoplanet that can potentially host life. It's called K2-18b, and it's a world you'd want to visit. K2-18b isn't exactly like Earth, it's more like a super Earth. Yeah, it's 2.6 times larger and almost 9 times more massive than our planet. Scientists think it could be a Haitian exoplanet, which is just a fancy way of saying that it likely has a hydrogen-rich atmosphere and is covered in liquid ocean. That means that K2-18b could be home to alien life. Only it would take a really long time to get there. If you were hurtling toward this space rock from Earth, you'd reach your destination in about 1.3 million years. Yeah, you heard right. Million. K2-18b has a lot of methane and carbon dioxide in its atmosphere. That's not exactly breathable air, so you'd still need a spacesuit to walk on this world. And I wouldn't be too hyped up about its ocean either. If an exoplanet has liquid on it, it doesn't mean that the liquid is water. It could be methane or ammonia, even acid. Like, even in our own solar system, there's a moon covered in liquid lakes, but these are methane and ethane lakes, and I wouldn't recommend swimming there. K2-18b could have a pretty mild temperature. For an exoplanet, that is. At minus 100 degrees Celsius, you'd find this world incredibly cold. Now, the most exciting thing we've found out about this world is that it could have traces of dimethyl sulfide. Woot woot! Well, on Earth, this molecule can only be produced by living things, and that means K2-18b could be home to alien life. Now, it doesn't mean that this life would be intelligent. It could be aquatic or microbial. Maybe even complex life if the conditions for it are just right. We won't know for sure unless we travel to explore this interstellar world. Now, how do we know all this? Well, we had the James Webb Space Telescope look at this distant world and take detailed measurements of its atmosphere. Most of the exoplanets have been discovered using what's called the transit method. It's when a planet passes in front of its star and blocks its starlight. That's when scientists study the wavelengths around the planets, and some of those wavelengths can tell us what kind of atmosphere those distant planets have. The problem is, exoplanets are really far away. Trying to figure out what their surfaces are like just by peering through even our most powerful telescopes is not easy. Some scientists will argue that K2-18b isn't a super Earth at all, but a mini Neptune. And that's a bummer because, as you know, Neptune is an ice giant. And if K2-18b is also an ice giant, then the chances for alien life on this planet don't look so good. Now, you don't have a million years to travel to this world to discover it for yourself, so maybe we should look at a world that's a lot closer to Earth. Like Proxima Centauri b. Proxima Centauri is the closest star we've discovered, only 4.2 light-years away from Earth. It's part of the Alpha Centauri star system, with not 2 but 3 stars orbiting each other. The exoplanet Proxima Centauri b orbits only one of these stars, but you'll still see the other 2 stars as bright dots in the sky. This exoplanet is slightly larger than Earth and revolves uncomfortably close to its host star. Luckily, that star is a red dwarf, and that's much cooler and smaller than our sun. Which is good news because that means this planet isn't getting toasted like Mercury. Scientists estimate Proxima Centauri b has an average temperature of about minus 39 degrees Celsius. That's pretty comfortable as far as alien worlds go. The bad news is that we still don't know much about the exoplanet's gravity or atmosphere. It might be our best candidate to set up an interstellar base, but It also could have a harsh environment, unsuitable for humanity's future home. It might even have an ocean of acid, or something deadly like that. The only way to find out is to travel there. And if Proxima Centauri b doesn't work out, well, don't worry, there are plenty of potentially habitable worlds out there. Like this one. Ross 128b is 11 light-years from Earth. It's the second closest potentially habitable world scientists have discovered. And it's more promising than Proxima Centauri b. The thing is, they both orbit red dwarf stars, only Proxima b's host star is a lot more active and violent. It occasionally erupts and bathes Proxima b in radiation. Ross 128b's star is nice and quiet. And even though this world orbits 20 times closer to its star than Earth is to the Sun, it still lies in the habitable zone. Because like I said, red dwarfs are way cooler than the Sun. And by cooler, I just mean temperature. This world could have a balmy average temperature of 23 degrees Celsius. That's only slightly hotter than the average temperature here on Earth. I don't know about you, but I could settle there. Now, we don't know enough about this world to call it our new home. It likely has lots of harmful radiation reaching its surface, and its atmosphere might not be breathable. But hey, that's not much worse than Mars. With efficient life support systems in place, we could make it work. Besides, this super Earth might have its own life on it. If Ross 128b did have alien life, it could be extremely different from what you might imagine. Just think about making the first contact with an alien species. What would that be like? I mean, it could go very wrong, too. For one, we might not survive the trip to any exoplanets, even the nearest ones. So far, we've discovered and confirmed over 5,000 alien worlds. 63 of them are potentially habitable, but we just can't know for sure. Most planets we've observed are extremely scary. Hey, you know what? After looking at Ross 128b, maybe traveling to other planets isn't all that horrible. Okay, so we've talked a lot about space today, but let's bring things back down to Earth. Literally, our gorgeous green and blue home. Now, even though we've been on Earth for what seems like forever, crisscrossing the continents, sailing the 7 seas since the beginning of time, human time, there have been debates about whether Earth is really round or if it's flat. Well, today we're going to disagree with the scientists and side with the flat earthers on this one. We're going to take a look at what would happen if the Earth was actually flat. Hey, who knows? Maybe what you find out will knock you off the edge of the Earth. If the Earth had an edge, I hope it would look like this. The edge of a flat Earth. I know, we've talked about it before, but there's something mesmerizing about it. A flat Earth solar eclipse? Diagonally growing trees? The Great Wall of Ice, guarded by NASA, of course. The flat earthers sure have a great imagination, but what if they were right? How would the Earth hold up in space? Would it revolve around the sun, or would the sun rotate around it? And why would you never walk to the Earth's edge? This is What If, and here's what would happen if the Earth was flat. In case you missed the news on the Flat Earth channel, here's a quick recap. For thousands of years, the general public thought that the Earth was flat and everything revolved around it. Then, Nicolaus Copernicus came around with his spanking new theory. The theory said that the Earth wasn't flat and definitely not the center of anything. His observations led him to believe that our planet is orbiting the sun. But here we are, 500 years later, and some people around the globe are convinced that the Earth is flat. Well, how would this even work? Do you know why the planets form in a spherical shape? One word: gravity. Gravity is what's pulling matter together equally from every side. And as a result, matter forms into a sphere. Of course, this wouldn't be the case for a flat Earth. Anti-round earthers think that there's no such thing as gravity. We only feel like there is because some mysterious force is accelerating the pancake-shaped Earth upwards. I don't need to tell you that you can't increase the speed forever. At some point, you'd be going too fast. Ugh, does anybody feel like a burnt pancake? No? If you want some real science, then yes, there would be gravity on a flat Earth. And it would be weird. The center of gravity on a flat Earth would be right here, in the middle. Everything on Earth and around would be pulled to this point. And the further you got away from the center, the stronger this pull would be. At some point, it would begin to pull you downward, so you would have to start climbing. This would be the reason why you couldn't walk to the edge of a flat Earth. Gravity would be so strong around there that it would be impossible for you to make it. You might never see the gorgeous 45-meter tall wall of ice called Antarctica, guardrailing the Earth's edge. And you'd never learn what's on the flip side. But at least you wouldn't fall off of it. There would be other side effects of this funny gravity. Objects closer to the edge of the Earth would fall sideways instead of down. Gravity would also make trees grow diagonally on most of the pancake-like Earth, because they'd be reaching against the pull of gravity. All the rain, snow, and hail would fall toward the Arctic at the center of the Earth. The precipitation would converge and start to build up. The oceans would get sucked to the center of the disk too, and form one big ocean in the middle. A big concern would be the air pressure on a flat Earth. Gravity would draw too much air toward the Earth's center, leaving the areas around the edge with no air pressure at all. That would be bad because people living in a flat Earth Australia wouldn't have enough oxygen to breathe. And if you lived closer to the middle, where the Arctic would be, you'd be crushed by the weight of the atmosphere. But not for long. A flat Earth wouldn't have a geomagnetic field around it. This field is generated by the movements of the Earth's core, and, well, a flat Earth just wouldn't have one. Nothing would be holding our atmosphere in place, and eventually, it would spill into space. We'd be exposed to solar radiation that would cause cancer and damage our DNA, and we'd have no breathable air anywhere on the planet. So, I hope you're able to find a life support system lying around. Now, let's get to those questions we've all been waiting for. What would orbit what in this arrangement? Would there be a day and night cycle? Or time zones? Every flat earther knows that the sun goes in circles around a pancake-shaped Earth, and so does the moon. They're both around 50 kilometers in diameter and act like huge spotlights. But let's bring good old science to the equation. If the sun worked as a spotlight, you'd see it from everywhere on Earth, even if it didn't shine directly on you. It would look like those alien abduction scenes. I wonder where they got that idea from. In this system, there would be no day and night cycle. That would be pretty strange. How am I supposed to get my beauty sleep? Okay, I know how to fix this. Yeah, that's better. For a flat Earth to have days alternating with nights, the sun would have to orbit the planet this way. When the sun was up, the entire planet of Earth would experience daylight, and when the sun went down, the Earth would fall into nighttime. There would be no time zones and no seasons either, but you could still mess up your schedule by staying up late and watching what-if videos. You'd be lucky if the sun was so much smaller than the Earth. Sort of. Think of this. If the sun retained its gigantic form as it was orbiting a flat Earth, it would burn down the entire planet. That's because of how close it would get to us. On the other hand, if the sun were much smaller than it really is, we'd freeze to death. That's because the flat Earth would have nearly 2.5 times the surface area of our round Earth. We'd be getting only 1/3 of a regular-sized sun's energy. That's not enough for life on a flat Earth to exist. And we haven't even talked about this yet. The lunar eclipse. Flat Earth disciples believe in some kind of anti-moon that's responsible for these. On our round Earth, lunar eclipses happen when the Earth lines up between the sun and the moon. If that was the case for a flat Earth, this is how those eclipses might look. And even that would require some very special alignment. So, if the flat Earth conspiracy turned out to be true, that our globe was indeed photoshopped and GPS devices were rigged for some financial gain, well, that would open up a conversation to other conspiracy theories. Unfortunately, many people, including the flat earthers, are living in a state of cognitive dissonance. That's when their thoughts and beliefs aren't quite consistent and don't always represent reality. I mean, we are constantly exposed to pseudo-evidence that can support any theory at all, even if it falls flat with a bit of logical thinking. If Copernicus had spent 10 hours on YouTube watching flat Earth conspiracy videos, even he might have admitted he was wrong. Okay, that's it for today's seemingly spectacular stumble through space. I hope you gained some valuable insights into what lies beyond and into some of the more wacky planets in our neighborhood. You know, here at What If, we like to investigate everything science related, from outer space to natural catastrophes. We cover it all. So if you liked this marathon, well, be sure to subscribe for plenty more videos just like this. All right, friends, that's it from us today. Thanks so much for watching, and we'll see you next time.